Hello, thanks for clicking. Welcome to another Nargilus 2 production. Today we're going to be learning about the P series and a special type of P series called the harmonic series. Okay, this is again our continuation of our effort to figure out all the different ways that we can decide whether or not a series converges or diverges, all the different tests that we can use so that we can put them all together and work with all of them to determine whether any series converges or diverges. Okay, so let's take a look. So what we're going to do is we're going to use the improper integral, all right, to determine for what values of p a series from 1 to infinity, 1 over n to the p converges or diverges. P is a number, okay? And for now, we're going to say p is not equal to 1, all right? And there's a reason for that. We'll see it in a minute, and then we'll throw in p equals 1 in just a moment also, okay? So to use the integral test, or we're going to take the limit as b goes to infinity, right? We're going to integrate the improper integral. So from 1 to b, it's 1 over n to the p dn. Now, 1 over n to the p. Remember, p is a number. So this is like looking at 1 over n squared, 1 over n to the half, 1 over n to the fifth, 1 over n to the 10th, whatever it may be. So to do this problem, we need to use the power rule. So we're going to have to bring the n to the p to the numerator. Let's do that first. Make it n to the negative p, and then we're going to integrate it. So let's integrate this thing. B goes to infinity. It's going to be straight line from 1 to b, n to the negative p plus 1 over negative p plus 1. Okay, now we're going to plug in. So we have the limit as b goes to infinity. Remember, b goes in for n. N is the variable of integration. So this is b to the negative p plus 1 over negative p plus 1 minus 1 to the negative p plus 1 over negative p plus 1. Okay, now we have to try to figure out for what values of p this thing will converge and what values of p it will diverge. All right, so let's look at some observations here. We're looking for convergent versus divergent. So divergent means that the whole limit would end up going to infinity. Converges means you end up at a finite value. So first things first, this term here, the 1 to the negative p plus 1 over negative p plus 1. P is some numeric value that's not 1. So that's going to be 1 to a power over whatever that number is. Take the negative and add 1. So this thing is going to be a number. This term does nothing. Okay, it does nothing to the problem to determine whether it converges or diverges. We're worried about a finite value versus infinity, right? So this is going to be a number. It does nothing. So everything rides on this first term here, b to the negative p plus 1 over negative p plus 1, okay? Because b is what's going to infinity. So this infinity right now is the base, and then it's raised to some numeric power. So the question is, how can I determine whether or not this term will go to infinity or it'll be a finite value? Well, first things first, the negative p plus 1 that's in the denominator, again, it doesn't do anything. This is a number plus 1, right? So that does not determine anything about convergence or divergence. This is just going to be a number. This really doesn't matter either. The only thing that matters is this term that's in the numerator, b to the negative p plus 1. So the question is, how would that determine whether or not this limit would go to infinity or be a finite value? Well, I think everything determines or it rides on whether or not b, the base, which is infinity, is in the numerator or the denominator. If the infinity is in the numerator, ends up in the numerator at the end based on the power, then the whole thing's going to infinity and it diverges. If the infinity ends up in the denominator with a power, then that's going to be 1 over infinity raised to a power, which is going to be 1 over a number really big. So the result will end up being really small. Okay, so the question is, which one is it? Right? So this is either going to end up as infinity to a power, and that's going to go to infinity, or it's going to be 1 over infinity to a power, and that's going to go to 0, right? Because it's 1 over something really big. So that's the question. All right, so then how do we manipulate this power? Well, what would determine whether or not this term is in the numerator and denominator? It's up to the power. If the power is negative, then this whole thing ends up on the bottom. If this power, when we're done, is positive, then the whole thing stays up top. So, one of two things can happen. For this power to end up being negative, we would need, so the power to be negative, we would need negative p plus 1 to be less than 0. So that would mean if I move the negative p over, p would have to be greater than 1. For the power to end up positive, then negative p plus 1 would have to be greater than 0. So that would mean if I add p on both sides, I get 1 is greater than p. So p would have to be less than 1, right? So again, you can try it. If p, let's say p was less than 1. P is negative 5. Put negative 5 in here. Negative 5, but the opposite of that is 5. 5 plus 1 is 6. Now I'll have infinity to the 6th. That's going to infinity, and it's going to diverge. Okay? So when the power ends up positive, it diverges. When the power ends up negative, it converges. All right? And again, same thing here. For p to be greater than 1, if p is 3, negative 3 plus 1 is negative 2. But that means b to the negative 2 ends up on the bottom in the denominator. So that's b squared on the bottom. So that's infinity squared. But in the denominator, 1 over infinity squared goes to 0. And this is a number, so the thing would converge. Okay, so now, so far, we're doing pretty good. We know it converges if p is greater than 1. It diverges if p is less than 1. But what if p is 1? Well, let's just do it. If p is 1, we end up with the limit as b goes to infinity, the integral from 1 to b of 1 over n to the 1. So 1 over n. The integral of 1 over n is the natural log. So this is a straight line from 1 to b, the natural log of the absolute value of n. I can substitute in. It's going to be the natural log of b minus the natural log of 1. Natural log of 1 is 0. But as b goes to infinity, the natural log of infinity, again, natural log graph looks like this. That goes to infinity. So this diverges. So at p equals 1, it also diverges. Okay, so there we go. This thing converges if p is greater than 1. It diverges if p is less than or equal to 1. That is the p-series test. So the p-series test is a series of the form 1 over n to the p, converges if p is greater than 1, diverges if p is less than or equal to 1. We literally just did it. We just showed it. Okay, now, a special series, if p is equal to 1, the sum from n equals 1 to infinity of 1 over n is called the harmonic series. Okay, it has a special name. It's called the harmonic series. All right, so we can throw that in there as well. All right, so let's use the p-series test. This one's one of the easiest ones to use. So we're going to determine if the given series is a p-series. Remember, p-series are 1 over n to the p, where p is a number. If it's not, state the test that needs to show its convergence or divergence. So let's take the sum from n equals 1 to infinity of 1 over the cube root of n. So that's 1 over n to the 1/3 if I rewrite that with exponents. But this is a p-series, right? And p is less than or equal to 1. So this diverges. And that's it. That's all you got to do. Okay, 1 over n to the 6th. Again, that's another p-series. Let's see, we have p is greater than 1. So this converges by the p-series test. All right, this one's a little more awkward. We have n squared. But n squared could actually be written as 1 over n to the negative 2, right? Normally we don't write it like that, but that is technically a p-series. P is less than or equal to 1, so this diverges. Okay, P is -2 there, P is 6 there, and P is 1/3 there. Also note that we could have done this series with the nth term test, right? For divergence, the limit as n goes to infinity of this is infinity, it's not 0, so this would diverge by the nth term test also. So now we can start getting into, again, multiple tests on the same series. Okay, let's try. Well, this is really 1 over n to the 5th to the 1/4. So that's really the sum of 1 over n to the 5/4. So that's a p-series. In this case, p is 5/4, 1 1/4. That's greater than 1, so this converges. Here we have 1 over 2 to the n. Well, wait, this is like backward, right? It's supposed to be, p-series is n to the power, n to a numeric power. This is a number to a variable power. So that can be rewritten like this. This is a geometric series, right? R is between -1 and 1. So this converges, but it converges by the geometric series test. R is 1/2. And finally, we have 2 minus pi. So that's, let's see, if we bring that to the denominator, that would be 1 over k to the -2 plus pi. So 3.14 minus 2 is about 1.14. Okay, well, that is a p-series. And p is greater than 1. P is about 1.14. So this converges by the p-series test. All right, and that's all there is to this p-series test. Okay, as always, thanks for clicking.